So if we're referring to limestone, sometimes we use calcium carbonate, the word, or the symbols, and the other way around as well. And to get limestone, we quarry. So quarrying is a method of getting limestone from the earth, and then we can go and use the limestone and turn it into lots of useful products. And it says there it's a useful building material. So the first reaction that you need to know about for limestone is this one here called thermal decomposition. Now if you think about what that word actually means, you've got the word thermal there, which means heat, and decomposition from decompose, which means breaking down. So this reaction is something breaking down using heat, thermal decomposition. And what happens is if you get your calcium carbonate here, and if you heat it up, and you can do this on a Bunsen burner, and a lot of you will have probably done it in class, is if you heat it up, it starts to glow, sometimes it goes yellow, and you make two new products. You make calcium oxide and carbon dioxide. Now you can't see the carbon dioxide because it's given off as a gas, but you're left with calcium oxide, and the symbol for that is CaO. Now this thermal decomposition isn't just specific to calcium carbonate. The same thing happens if you change the type of carbonate that you've got. So if you've got copper carbonate, you heat it up, it thermally decomposes to make copper oxide and carbon dioxide. Zinc carbonate does the same to make zinc oxide and carbon dioxide. And magnesium carbonate does the same to make magnesium oxide and carbon dioxide. Hopefully you can see this pattern. So if there's ever an exam question about thermal decomposition, you're going to get a metal carbonate, and it's going to break down under heat to make a metal oxide plus the same gas, carbon dioxide. There's a pattern there. So you need to know the pattern, you need to know what happens when each of these carbonates are broken down under heat to make a metal oxide and the gas, carbon dioxide. The next thing that you need to know is where this fits in to another set of chemical reactions. And what we look at is a series of reactions called the limestone cycle. Now we've already learnt the first one, we've just looked at it. So that one hopefully we're okay with, is this thermal decomposition. So there you've just seen it on the previous slide. Calcium carbonate, you heat it up, you make your calcium oxide and carbon dioxide. Now what you can then do is by using the calcium oxide, if you take the calcium oxide and if you add some water to it, you can make calcium hydroxide. So if you look at the symbol equation there, you've got your CaO and you're adding H2O to it to make CaOH2. You're adding water to make a hydroxide. So that's the second equation that you need to know. Now, the other name for calcium hydroxide, if you've added enough water to it, is lime water. So calcium hydroxide is also called lime water, and if you add carbon dioxide to the lime water, and some of you will have seen this done in class, what happens is you make calcium carbonate. And if you remember, calcium carbonate was what we started with when we did the thermal decomposition, and calcium carbonate is the limestone. This last reaction here, if you've got calcium hydroxide, which is your lime water, and if you bubble the carbon dioxide through it, you're making these tiny little particles of limestone, so you're going full circle, and then the other product is water, which if you look at the symbols, you'll see that there's some hydrogen there and some oxygen still left over, so there must be some water in the products. Each of these three reactions are really important, and you must learn them to understand fully the whole limestone cycle. This calcium hydroxide that we've just talked about, and remember the other name for calcium hydroxide is lime water, if enough water has been added to it, can be used to neutralise acids. So if you've got calcium hydroxide, or here it is down here in the limestone cycle, because it's an alkali, if you add it to acids or acidic soils or acidic lakes, you can neutralise them to increase the pH and make it more towards pH 7, a neutral pH. So that's an application, that's a use of calcium hydroxide, is because it's an alkali. Farmers can use it, or other people in industry can use it to neutralise things. And the example is to neutralise soils so plants can grow better, and to neutralise lakes so that the aquatic life don't all die off, because if it's too acidic, a lot of fish and a lot of plants won't survive. Another really important point is this point here, is when we're talking about lime water, a really common use of lime water, or calcium hydroxide, whichever word we're going to use to describe it, is used as a test for carbon dioxide. So you might be asking in an exam, what could you do to prove that carbon dioxide was given off in the reaction? And what you would say for your answer is that you can bubble the gas through lime water, and if the lime water turns cloudy, then you've got carbon dioxide. So a positive test for carbon dioxide is that lime water goes cloudy. So you need to make sure you describe the process in full. If you had a different gas like oxygen or hydrogen, and if you bubbled it into lime water, it wouldn't go cloudy, so you would know that you didn't have carbon dioxide. The last set of reactions that you need to know about on this topic about limestone is what happens when you add some acids to these carbonates that we've talked about before. So we saw these when we were talking about thermal decomposition and what happens when you heat them up. Now we're going to look at what happens when you add them to an acid. And you need to spot some patterns, and you need to be able to name the products. So here I've got sulfuric acid and copper carbonate. Whenever I've got an acid and a metal carbonate, like all of these examples here, I always make a salt, a different type of salt with different names, and water and carbon dioxide. Now straight away I'm thinking, for this example, this reaction, they could use this, the examiners could use this to test your knowledge of how to test for carbon dioxide. So they could say something along the lines of, what is the product when sulfuric acid and copper carbonate react? Or what are the products? And you might have to name all three products, and then you might have to describe how you know or how you could test for carbon dioxide. Linking it back to this idea that you could bubble it through lime water, and if it goes cloudy, you know you've got carbon dioxide. In all of these reactions, carbon dioxide is there, so if you did bubble it through lime water, it would go cloudy. But just have a look at the pattern. Sulfuric acid plus copper carbonate makes copper sulfate plus your water plus your carbon dioxide. The next example, sulfuric acid plus magnesium carbonate, goes to magnesium sulfate and water and carbon dioxide. The salt is named by the metal plus a little bit of the acid. So the acid, the name of the acid changes in a salt. So if you've got sulfuric acid, you're always going to get sulfate. Down here, if you've got nitric acid, you're always going to get nitrate. And if you've got hydrochloric acid, you're always going to get chloride. For these reactions, remember, you've always got your water, you've always got your carbon dioxide. So if we have a look at one of these examples down here then, if I've got hydrochloric acid plus copper carbonate, I'm going to get copper chloride, because I'm using hydrochloric acid, plus water, plus carbon dioxide. An important example is this one here, where I've got sulfuric acid plus calcium carbonate, which hopefully we should now know as limestone. If you react those together, you end up with calcium sulfate plus water plus carbon dioxide. Now the example here relates to acid rain because sulfuric acid is the acid, one of the main acids, which is produced in acid rain. So sulfuric acid can be formed in the clouds. If that rains down onto the ground, if it reacts with a limestone statue like you see here, reacts with the calcium carbonate, it wears away and erodes the rock, you're left with calcium sulfate and water and carbon dioxide. So just remember, calcium carbonate is damaged by acid rain. The last little bit on this section is about concrete. So you need to know what concrete is made of, what are the main ingredients in concrete, and limestone plays a really important part in this. So concrete is made up of crushed rocks, also called aggregate, water, cement and sand. So those are the four main ingredients: crushed rocks, water, cement and sand. And a property of concrete is that normally it's very strong. You can change the amounts of each ingredient, and if you change the amounts of each ingredient, for example, if you change the amount of rocks, the strength of the concrete will change. So by mixing up the different amounts of ingredients, you can change the properties. The other thing that you can do to make concrete stronger is by reinforcing it with steel.